So every time a PHP application has to transfer a whole array to the client and back, the PHP application developer has to choose a way to do that. And traditionally, they were all lazy and just used serialized and unserialized. So they put the array to serialize and just use a string, for example, for a hidden form field. And this is the most of the time you see unserialized and serialized content in hidden HTML form fields or in the cookie. Actually, this is an example from TikiWiki. And TikiWiki is even more nice. It's just unserialized two request variables, which is a collection of pages that is supposed to be printed. And it will do some modification of this data. And later, the modified data is serialized again and given back to the user. This is very good for an attack. And you see later why. So why do people do that? The reason for that is PHP code is usually very old, and they all learned programming in PHP 4 days. And in PHP 4, it was not so dangerous to use unserialized because there were no destructors, so there was no unintended code execution. And wake up methods were very, very, very seldom, and you have to program on your own. So usually no one used wake up, so there was no danger at all, except for vulnerabilities in the unserialized parser, and we had a lot of them in the past. So the next thing you would see in modern PHP applications is that they always use some kind of caching, because they're usually too slow, so they cache a lot in memory, in the database, or in files. And of course, files are still the most often used thing to store big data arrays. So you will see that a lot of PHP applications store serialized data in files. What does this mean? This means, first of all, when the application is able to store serialized data in files, this means there must be some directory on the web server that is writable, because otherwise it cannot be cached. It's not necessary that this is inside the document root. This can be anywhere on the server, maybe the temp directory or a subdirectory of the temp directory. But there must be a single directory that's writable. So this also means when there's a file upload vulnerability in the application, there must be a single directory that's maybe writable for the file upload. And normally when you can upload something in a temporary directory, and the temporary directory is not accessible, that's usually not a problem for an application. So it's a file upload vulnerability maybe, but it's not ranked so high in severity because you cannot do anything with it. But when you take the caching files into considerations, now when you can upload a file to this temporary directory, you can upload maybe a cache file that is used later and unserialized. So you can attack unserialized again. So the next part where you see unserialized and serialized very often is when you look at the web application programming interface, the web API. Many PHP-style web applications will provide a serialized and unserialized way to maybe talk REST. They don't use JSON, they use serialized and unserialized. The most popular application like this is WordPress. So when you have a WordPress blog, it will talk from time to time with api.wordpress.org in PHP serialized and unserialized form. And the problem here is it's talking HTTP, so any kind of HTTP man-in-the-middle attack can inject malicious serialized data into your unserialized on your blog. Actually, this example is really taken from WordPress. So you see it will send some requests to the WordPress API and check if there's a new version of a plugin, and then we'll unserialize the code. And and if WordPress would have interesting objects, this will be a remote code execution vulnerability. But luckily there's no such object. So only if you have a vulnerability in the parser you can maybe attack WordPress. The next thing where you find unserialized is with databases. There are a lot of PHP applications that store settings or sessions in a serialized form in the database. This means if you have a SQL injection vulnerability in a PHP application, you maybe can modify the field that is serialized. With older PHP applications, this was very tricky because you cannot stack queries with MySQL in early PHP versions. But nowadays, especially all these Zen framework applications, they use PDO MySQL to access the MySQL database. And PDO MySQL has no protection against stacked queries. So when you have an application with PDO MySQL, you can inject the usual semicolon drop tables. And this was not possible previously. But now you can do that with modern applications, and so you can modify all the database. Okay, when you can modify all the database, maybe you can do other interesting things, but you can still attack unserialized. Actually, I did an audit for our sister company, Mayflower, who develops a PH project. I did this in February, I think, and they have unserialized of database content, and they also had a SQL injection, so I was able to unserialize something and execute arbitrary code. The last thing I want to get into is a vulnerability I disclosed during the month of PHP security in May. It was actually the last one, on the last day. And the thing is that there is a problem in the session deserializer. And the problem is whenever a session key starts with an exclamation mark, this deserializer gets confused. And so if you have an application that allows you to put arbitrary keys into a session, or to have a prefix, arbitrary prefix for session variables, which sometimes happens. You see some examples down there. When something like this exists in your application, then you can more or less inject exclamation mark keys with arbitrary values. And now the problem is when this gets deserialized during the session load, it will confuse the deserializer, and suddenly you can inject arbitrary serialized data into the session. Okay, if the application allows to put anything in the session, then you can put anything in, but these are always strings. But due to this vulnerability, you can put anything serialized in there. So you can attack unserialized, or you can just create arbitrary objects anyway in the session, maybe a valid user object. Normally you can just inject a string, but with this vulnerability you can inject an arbitrary user object if your application has something like this. So these were the vulnerability classes that could allow attacks against unserialized, but to do property-oriented programming, you need more. You need, first of all, you need this deserializing of malicious input, but you also need classes that are usable for your POP chain, your property-oriented programming chain. And a class is usable for the POP chain if it can start the POP chain. Okay, first of all, the class must be available in the application and at the time of the unserialized. Then you need something to start the POP chain. You need something to transfer the control from one object to the other. And in the end, you need some object with interesting operations. I will go on this later. So, first of all, class availability. When an application unserializes something and it creates objects, then you can only create the objects that PHP knows about at this moment. So this means if you unserialize an object called XABCD, then PHP will check if this object is available, if this class is available, and if it's not available, it will create a so-called incomplete class, which is nothing more like a dummy object with properties. So this is not usable. So basically this means you can only use classes for your attack that are already included at the moment of the unserialize. This limits very much the amount of classes you can use for the attack. On the other hand, Modern PHP applications have the possibility to register a so-called autoload function, which is a class autoloader. So in the case PHP doesn't find the object, it will first call the autoloader, and the autoloader can check if it knows the class or knows how to load the class or create the class. So in modern application, you sometimes are able to instance every single object of the application because the autoloader will just load the right object at the right time. So I already said you are really limited in how your pop chain will look like and what methods you can use. So the problem in PHP is you have to find a way to start the chain at all. So and this means your unserialized must somehow, or the code afterwards must somehow trigger execution of the objects you just created. And I already mentioned there's wake up and there's destruct. These are most obvious ways to start a pop chain. But there are some other magic methods in PHP that might allow you to start a pop chain also. This is toString. So every time you have an object and it gets concatenated to a string, it will call the toString. So maybe you find a usable toString method. When a method is called on an object and the method is not known, then it will try to find the call magic method. If it exists, then it will execute that. And get and set are for magic properties, so the getter and setter. In real world, so far, I only started pop chains with wake up and destruct. So the others are theoretically possible, but so far I haven't found an application that is vulnerable to this. And the example just shows you have a class, I call it PopStarter, and it has a destructor. So when you unserialize this class and it will get destroyed, the destruct will be executed. In this case, there's nothing in there, so nothing would be happening. So the next thing you always need in a pop chain is a way to transfer control from one object to another, to the method of another. Because you usually will not find a destructor that does something very interesting for you. In the past, you could find destructors that were deleting files, so you could delete a file immediately. Or you find something that writes a log file, so you could write a file to the disk. But most of the time, the destructor will do nothing else than call like another method of another object. So you need a way to transfer the control from one object to the other. The most obvious thing is that you have a property that gets dereferenced and the method of this new object is executed. You see this in the example, the property 2 is used as object and the method B is executed on the property, on the other object. Another way would be that property 3 is also an object and the data property is assigned some value. So you maybe can hit a magic setter in another object. And the third thing is a property is appended to a string, so you could hit a toString method of another object. So this always transfers execution from one object to the other. And usually you want to chain many of them until you reach a method that is usable for you. And these are the end of pop chains are usually classes with interesting methods. This means an interesting operation is